Good morning, everyone. Let us start with few more properties of Z transforms. In the previous class, we had covered the linearity property and also the time shifting or the translation property. We had done in detail, and we had discussed regarding the region of convergence and few properties, yeah, like linearity and time shifting. And we were about to discuss regarding the multiplication by an exponential. Okay, so let me share my screen now. Okay, so now the next property, the third one, is multiplication. Is multiplication by an exponential, by an exponential by an exponential. So now I have multiplication by an exponential. So if I have a discrete signal, say x of n, it is general one. I want to take its Z transform, it would be x of z. So now multiplication by an exponential. So what is the operator? That is multiplication. That is the mathematical operator, and it is exponential in nature. So what I do here is I use a power n into x of n. So I need to take the z transform of it, out x of z, and after finding out x of z, wherever z is there, you need to replace by z to z by a. Okay, so what happens there is, if you find out z transform of any given signal, so you will find out a given signal z transform, that is x of z. So if it is multiplied by a power n, okay, I repeat, if it is multiplied z to z by a. Okay, so that is how you can find out the property, which is nothing but the multiplication by an exponential. So in order to find out this multiplication by an exponential, I can generally go for the given z transform, right? So from the definition of z transform, that would be n equals minus infinity to plus infinity. So x of n signal z power minus n. So I have, that is a power n x of n, okay, z power minus n. So I can group the terms here. Sigma n equals minus infinity to plus infinity x of n z power minus n, okay, z power minus n and a power n. Okay, so now what I can do here is I can make a slight change as n is equal to minus infinity to in plus infinity. I have x of n, so that is having a divided by z power n. Okay, so I'll change it as n equals minus infinity to plus infinity x of n z by a, that is whole raised to the power minus n. Okay, so look at this z transform of a given signal x of n, which I want to write it. I can define it mathematically as n is equal to minus infinity to plus infinity a function x of z. In place of z, I have x of z by a. In place of z, I have x of z by a. So this is the multiplication nature of a given function x of n, that is given signal x of n, multiplicating or multiplying by a. Okay, so z transform would be this one, and where I'm going to replace z with z by a. Okay, so now it's the region of convergence. The region of convergence. So how do you find out the region of convergence? As I already told you, that is Rx minus, so Z Yeah, simple one, Rx plus. So two different ranges, your ROC will exist. So now this Z is replaced by Z by A. So that is Rx minus, that is given by Z by A, that is less than Rx plus. Okay. So mod A Rx minus less than mod Z less than Rx plus multiplied with A. Okay. So this is the region of convergence, that is ROC. So ROC will exist here. Okay. So now this is how I can write it for the multiplication, multiplication, multiplication by an exponential, multiplication by an exponential, multiplication by an exponential. Okay. So going on to the next one, I have ramp, multiplication by a ramp, multiplication ramp, multiplication by a ramp. Okay. So now if I want to find out Z transform of a given signal, say x of n, that is x of z. Okay. Now multiplication by a ramp. So as I already told you, n into x of n. So n is nothing but I'm taking it as a ramp function here and multiplying with the given signal. What I'm going to get, I'll be getting minus z into d by dz of x of z. Okay. So first what you are going to doing, what you will go, you are going to find out the z transform as you already do and differentiate once, then multiply with minus z, multiply with minus z, multiply with minus z. Okay. So z transform of n into x of n, that would be minus z d by dz, d by dz into by a ramp. Okay. So in order to multiply by a ramp function, I can x of n and I can define it as sigma n equals minus infinity to plus infinity x of n z power minus n. Okay. So now in place of x of n, I'll be having n into x of n, but I'll be going for a slight change here. Equation. Okay. So differentiating equation 1 with respect to z, with respect to z. So what I do here is, what I do, I differentiate with respect to z here. So this is a constant. Okay. I'm going to differentiate only this parameter, that is z power minus n. Okay. So sigma n equals minus infinity to plus infinity x of n z power minus n into, that is minus n. Okay. So that's how we are going to define the differentiation of minus n, I think n minus n minus 1. Okay. Minus n minus 1, z power minus n minus 1. Okay. Minus n which is there. Okay. Being multiplied. So next what I do here, I take the minus sign outside. So sigma n equals minus infinity to plus infinity x of n z power. Okay. Z power minus n minus 1. Okay. So what I do here, I can write like this also, that is with a negative sign, sigma n equals minus infinity to plus infinity x of n z power minus n into z power minus 1. Okay. So now this entire function here, what I'm going to represent it in that manner. Okay. So what I'm going to represent it, so I have this function which is represented as, I think I have missed out n here, sorry, I think I have missed out n. Okay. Yes, n into x of n z power minus n is there, minus n minus 1. Okay. So what do? I just have the multiplication being done here, right? So d by dz of x of z. Okay. Multiplying with z here. Okay. Multiplying with z, I'm left out with minus sigma n is equal to minus infinity to plus infinity n times x of n z power minus n. So n times x of n z power minus n. What is there? That is minus sign is to be multiplied to this side, and I have minus z d by dz times x of z. That would be equal to sigma n equals minus infinity to plus infinity n times x of n, that is multiplied with again z power minus n. So this is the given signal what is represented as a ramp. Okay, multiplying a signal with n will give rise to multiplication by a ramp signal, that is nothing but n. So this is z power minus n, and I can write it as the z transform. Okay, so this entire function here will give me the z transform, will give me the z transform of the given ramp, the given ramp, okay. So now I have n into x of n, n into x of n. So what I do here, so I have minus z into d by dz of x of z. So this is how I can represent, and it is quite easy to have the multiplication of ramp signal being obtained. Okay, so let's stop it here. In the next class, we'll be uploading the remaining two properties, that is convolution in time domain and also the time reversal property. Okay, later on we are going to solve with transforms of certain useful sequences, and we will have the sinusoidal sequence and few more numerical problems which are quite interesting. We will able to solve it in the next upcoming video. Okay, like right now I'll stop here, and we can